Okay, what I'd like to do now is introduce this concept of central integration of these visceral sensory signals so that the motor output can be coordinated by higher brain centers in the medial and ventral aspects of the forebrain. So I want to show you really an expanded, or maybe you might think of this as an exploded version of this illustration that unpacks exactly what these structures are and how they relate to the influx of sensory signals and then the output of our preganglionic neurons. So this is the last slide that I want to show you in this part of our tutorial, and trust me, it looks actually much worse than it really is. Let me give you a sense of the organization of this chart. What we have on the right-hand side of this chart is basically the ascending sensory information that is derived from our visceral sensory elements. Many of these things we've already discussed. So our end organs are giving rise to first-order afferents that are arising through cranial nerves 9 and 10 and the axons of our anterolateral system. And the nucleus of the solitary tract then becomes a very important integrator of this information. We've already talked about how the nucleus of the solitary tract gives rise to projections that impact our interneurons that organize the preganglionic neurons of the sympathetic and parasympathetic divisions in the brainstem and the spinal cord, and this thereby mediates local reflex activity that can alter the activity of our end organs. So what I want to introduce to you is the idea of a central autonomic network that is processing these ascending sensory signals and coordinating the output of our visceral motor effector systems through a broad distributed network of elements in the ventral medial parts of the forebrain, including some diencephalic regions, including the hypothalamus, very important structure that I'll talk about next, as well as parts of the brainstem. So from the nucleus of the solitary tract, inputs are passed into the reticular formation of the brainstem. They're also distributed directly to the hypothalamus and then indirectly to another nucleus of the brainstem called the parabrachial nucleus. This is found very near the superior cerebellar peduncle as it attaches to the upper part of the pons. Well, this parabrachial nucleus then sends input to the medial parts of the thalamus, to the hypothalamus, and to the amygdala. And once this information has access to the thalamus and the amygdala, now it can be distributed more broadly to the ventral and medial aspects of the prefrontal cortex. The thalamus and the amygdala have connections specifically with the insular cortex, and the insular cortex in turn has interconnections with the rest of the orbital and medial sector of the prefrontal cortex, which becomes very important in integrating the sensory signals that are being processed and impacting the motor output that eventually feeds its way down towards our brainstem and spinal cord networks of neurons. Well, let me just pause for a moment and highlight the importance of this insular cortex. We can think of this insular cortex as being the sensory cortex for the viscera. So one aspect of this insular cortex that I think is really interesting is its capacity to integrate these visceral signals and then use that information as a way of informing other kinds of networks that mediate different dimensions of cognition. So here's an example. Let me ask you a question. How do you feel right now? Well, if you're like me, you may respond based on information that is derived more so from the viscera than, let's say, from our cutaneous surfaces. Now, of course, you may have a condition by which your cutaneous surfaces or your musculoskeletal systems really drive the answer to that question, how do you feel? But I think for many of us, that response, whether we think of it in these terms or not, is really derived from our visceral senses. And that is a signal that is processed here in this insular cortex. So I think this insular cortex is very important for this notion of feeling. So how do you feel today? Well, let your insular cortex inform the rest of your cognitive networks as you consider your reply to that question. All right, well, let's move from the right side of this figure then to the left side. So as the insula has interactions with the rest of the medial and orbital aspects of the prefrontal cortex, we begin to coordinate and organize our plan of action, our governance of our visceromotor output. And this happens through multiple relays, some of which run through the amygdala and then through the hypothalamus. Others enter the amygdala and hypothalamic systems and then have more or less direct access to brainstem networks that organize our preganglionic, sympathetic and parasympathetic neurons. Well, eventually from that level then, of course, we have our motor outflow to our ganglionic neurons that can alter the activity of our end organs. So we might think of this medial prefrontal cortex then as the principal coordinator of outflow that is going to alter either our homeostatic state or prepare our body for action, that is for allostasis, to change the state of the body in order to once again restore conditions of homeostasis. Well, an important mediator then of activity from the level of the cortex to these brainstem effector systems in the reticular formation and then the preganglionics themselves is this part of the ventral diencephalon called the hypothalamus. The amygdala is important too, but we'll talk about that in a later session in the final unit of the course. I'd like to take a few minutes speaking with you about the hypothalamus and highlight for you its key role in integrating visceral sensory signals as well as command signals and contextual signals derived from the level of the cerebral cortex. And then the outflow from the hypothalamus is largely directed at our visceral motor effector systems, as we'll see in the next part of this tutorial. So if you'll hang with me, we'll move from this rather lengthy first part of the visceral motor tutorial, and I want to spend some time with you talking about the hypothalamus. But before we get there, consider this study question, and I think you'll be ready to move on after that. So I'll see you in just a minute, and we will pick up talking about the hypothalamus.